Voyager mission reveals an unexpected pressure at the edge of our solar system. Mike McRae of Science Alert reports NASA astronomers used data from the Voyager probes to measure the bustle of particles rippling at the very edge of our solar system and discovered the pressure in the distant borderlands of our star is higher than they expected. Why is that? The results suggest, quote, that there are some other parts to the pressure that are not being considered right now that could contribute. This is what Princeton University astrophysicist Jamie Rankin says. Maybe there are entire populations of particles out there that have not been taken into account yet, or maybe it's just a little hotter than anybody figured. The researchers have a number of possible explanations to explore in the future research. While the discovery itself is interesting enough, it's the way they found it that makes for a truly fascinating bit of science. As plasma in the shape of solar wind emanates from our sun, it forms a bubble, and we call the heliosphere, 14 billion kilometers away from the star. That wind effectively runs out of steam and charged particles rapidly slow to subsonic speeds. The edge of this bubble, called the heliosheath, is a zone where the density of those charged particles drops off and magnetic fields grow weak. Beyond this messy border is a thin shell called the heliopause, where the haze of plasma blown out by the sun trickles away, nudged by the subtle influence of our galactic neighbors as our star moves through space. At this pause, the pressure of local interstellar space pushing in and the heliosheath pushing out must balance out. Knowing exactly what this looks like, though, is no easy task. We can make models to estimate, but nothing beats hard evidence. Fortunately, we happen to have two probes passing through that part of the solar system. Okay, we have Voyager 1 and Voyager 2. You can take a look at NASA's handy diagram to see how all this fits together. Voyager 1 is about 20 billion kilometers away, effectively out in the wild emptiness we think of as interstellar space. Its partner, Voyager 2, is not far behind, right on the cusp of making an exit. Neither has a direct way of telling us much about the pressures of space in that area, but a recent flare-up in the solar activity called a Global Merged Interaction Region, GMIR for short, provided a prime opportunity to work it out. There was really a unique timing for this event because we saw it right after Voyager 1 crossed into the local interstellar space, Rankin says. And while this is the first event that Voyager saw, there are more in the data that we can continue to look at to see how things in the heliosheath and interstellar space are changing over time. The solar activity was effectively a shout into space, sending a pulse of particles roaring out into the distance. This cry rippled into the heliosheath in 2012, where Voyager 2 was watching and listening. Roughly 3 months later, Voyager 1 also felt its effects. From each set of observations, the researchers calculated that pressure at the boundary to be around 267 femtopascals, which is an absolutely minuscule fraction of the kind of atmospheric pressure we experience here on our Earth. It might be a relatively tiny squeeze, but the researchers were surprised. In adding up the pieces known from previous studies, we found our new value is still larger than what's been measured so far, Rankin said. The team were also able to calculate the speed of sound waves passing through this medium, a speed 314 kilometers per second, or 1,000 times faster than sound traveling through our own atmosphere. There was one other surprise to come. The wave's passage lined up with an apparent drop in the intensity of high-speed particles called cosmic rays. The fact each of the probes experienced the same thing in two different ways gives astrophysicists Yet another mystery to solve. Trying to understand why the change in the cosmic rays is different inside and outside of the heliosheath remains an open question, Rankin said. The Voyager probes might be getting a little old, but given how busy it looks out on the edge of the solar system, we're glad they have not fully retired yet. This research was published in the Astrophysical Journal, and it's on Science Alert. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.